Every journey starts with a first step. In electronics, Ohm's law is that step. Just as you can do mathematics without understanding addition and subtraction, you can tackle electronics without mastering this fundamental law. It's the absolute foundation. Without it, you won't understand what current is and how it flows, what limits it, why we need voltage, or why resistance exists at all. In this video, you will discover what voltage, current, and resistance really are, and most importantly, how these three quantities interconnect. This is essential knowledge. Without it, you can't move forward. I am Maciej Szewczyk, and on this channel, you will learn how to solder and understand principles of electronics. In the previous episode, we gained our first serious skill, soldering. If you manage to solder the resistors in lesson 1, that's great. Thanks to them, we will be able to check how current and voltage work in practice. Now, it's time for something equally important, because not only we will learn the fundamental law of the electronics world, but we will also make our first measurements with the multimeter. We will learn how to use it and how to do so properly and safely. The plan for this episode is to first discuss and understand the basic concept in theory, and then we will use the multimeter on the kit to check whether what we have learned actually happens in the real world. And if you want to learn electronics and soldering and have your own complete electronics kit, then I invite you to visit voltnova-labs.com. There you will get your home laboratory. Remember that the entire episode is available as an article on the website. There is also a circuit simulator there to help you understand today's topics. So if you don't like watching videos, I invite you to check out the article, and I will put the link in the description. End of introduction. Let's get into lesson 1. To make it easier to understand electronics, we can compare it to a water analogy. First factor is voltage, which we express in volts, and in formulas we denote as U, though sometimes you will find V or E. It doesn't matter which notation is used, the principles is exactly the same, and everything comes down to the same thing. We will denote voltage as U. In the water analogy, voltage can be compared to pressure in hydraulics. If you put finger against a tap, you will feel pressure. When you turn the water on more, this pressure will be even stronger, because more water will want to flow out. Simply put, voltage is like the pressure of water. Voltage can be constant or alternating. In our course, we will be dealing only with constant voltage, because that's what's mainly used when tinkering, playing with Arduino and Raspberry Pi. All batteries and rechargeable batteries are sources of constant voltage. The second type, alternating voltage, has a more complex nature and won't be described in detail here. We strongly advise beginners against experimenting with alternating voltage on their own, for example in wall outlets. A potential mistake could result in loss of health or life. This is not a game. That's why it's better to focus on the experiments described here, which are completely safe. The second factor is current, which we can imagine as water flow rate, the amount of water flowing in a pipe. You can compare it to the amount of current flowing in a wire. The unit is probably already familiar to some, ampere, and we denote current as I. To complete Ohm's law, we are still missing one factor, and you can probably guess what it is, because you are already students of complete electronics. Yes, it's resistance, which we denote with the capital R, and its unit is ohm. Analogous to the hydraulic system, resistance is a constriction that allows less water to flow through. In electronics, resistance limits the flow of current. Voltage is water pressure, current is water, and resistance is the valve. Let's create a simple animation of a valve that limits the amount of flowing water. The valve is in a fixed position, and when we increase the water level, which is equivalent to higher pressure, more water gets through to the other side. And when the water level is lower, less water will get through. The same happens with current. When we have a resistor with a fixed value and we increase the voltage, more current will be able to flow through it. And when we decrease the voltage, there will be less current. Keep in mind that voltage and current are directly related. When one increases, so does the other, while resistance limits it. Quick summary: an increase in voltage leads to greater current flow with the same resistance. Now let's change how the valve works a bit. The water level will be the same, but we will be adjusting the valve. Compared to electronics, we will be changing the resistance, but we will leave the voltage the same. This is time we can observe that the amount of water depends on the valve position. So at constant voltage, the current that flows through a given element depends on its resistance. The conclusion: the lower the resistance, the more current will flow in the circuit, and the higher the resistance, the less current. Remember that the resistance limits how much current can flow. So we have covered the water analogy. We know roughly how it works in electronics, what voltage, current and resistance are. Now we need to learn a few formulas and calculations. Ohm's law is actually 3 formulas. And this whole water analogy we saw is exactly Ohm's law. Look, the formula for voltage is U equals I times R. For current, I equals U divided by R. And for resistance, R equals U divided by I. Remember that in lesson 1 on the complete electronics kit, these formulas are printed directly on the PCB. These are really very important formulas and I will show you right away how to use them. Let's now draw the circuit from lesson 1 and analyze it. An electronic circuit is a closed system of electronic components, such as power source, resistors, capacitors, and integrated circuits, which are connected together in a way that allows current to flow and perform specific function. This is the symbol for power source, meaning our battery, and this is the symbol for a resistor. And these lines are simply connections between these elements. I won't talk about the resistor right now because that's a subject for the next lesson. For now, remember that it has some fixed resistance and it limits current. When analyzing electronic circuits, we assume that current flows from positive to negative. You might heard debates about how it flows, from negative to positive, or that current is an electric field, and so on. But one thing is certain and has been accepted since the beginning of electronic science. Analyzing circuits from positive to negative totally simplifies things and doesn't change how the circuit works. Our battery has a voltage of 9 volts and the resistor included in lesson 1 kit has a value of 1k ohm, which is 1000 ohms. I hope you know mathematical prefixes because in electronics we use them all the time. Let's calculate what current flows through this resistor. The formula for current is I equals U divided by R. The resistor is connected directly to the battery, so across the terminals of this element there will be 9 volts. And dividing this by the resistor value of 1000 ohms gives us 9 milliampere. So in our circuit on the complete electronics kit we should see a voltage of 9 volts and current of 0.009 ampere or 9 milliampere. We will go to the workbench in a moment and check whether what we calculated actually works in the real world. If we connected the resistor to 90 volts, we can easily calculate that current would be 0.09 ampere or 90 milliampere. This means that a tenfold increase in voltage causes a tenfold increase in current with the same resistance. An important note that often causes confusion. Unlike the water analogy where a valve reduces the amount of water, in electronics the current before and after the resistor is the same. Let's remember, however, that analogies are meant to simplify understanding, not reflect reality 100%. If in this lesson we had 10k ohm resistor instead of 1k ohm, which is 10 times larger, I can already assume that the current will be 10 times smaller than the 9 milliampere. But let's calculate it. 9 volts divided by 10,000 ohms equals 0.9 milliampere. So indeed, what I'm saying is true. Alright, so we have learned what voltage, current and resistance are, how they work together, how to calculate Ohm's law, and so on. Now we need to check whether what we calculated will actually match reality, but before we do that, here's a quick tutorial on how to use a multimeter. We are currently interested in 3 measurements, and you can probably guess its voltage, current and resistance. Let's ask ourselves the first question. How do we measure voltage? On the multimeter, it's easy to distinguish because alternating voltage is marked with a wave or the designation AC, which means alternating current. We are interested in the second one, which is DC, direct current, or marked with a solid line with a dash line. If you have an automatic multimeter, it's very simple. You set the multimeter dial to the DC voltage measurements. If you have a multimeter with ranges, like I do, you need to set a value that will fit within the given range. We have 9 volts, so a range up to 20 volts is perfectly sufficient. If you don't know the value, you move the range from the largest to the smallest until something appears and you have as many decimal places as possible, because this result will be the most accurate. We always measure voltage in parallel, never in series. This means that if we want to know the voltage value across a given element, we connect between one link and the other. Let's plug in the probes and measure the voltage ourselves on the kit. The black test probe should be plugged into the COM socket, and that's its only place. The red probe should be plugged where there is a V marking, so you need to see what markings you have on your multimeter. I have this marking here. Probes ready, meter turn on the set to the correct range. So now for a great moment in your complete electronics adventure. Your first measurements. We plug the battery into the kit and let's first measure the voltage across the battery. In this spot there are specially installed terminals. You can even see the power symbol. Remember to hold the test probes by the plastic housing elements. You should not touch the metal tips. This could distort the results, and in cases when measuring high voltages, it could end very badly for you. Minus to minus and plus to plus. It doesn't matter whether you touch from the side or from above. What's important is that you have a firm contact with the measurement point. Just be careful not to create a short circuit, meaning don't let the probes touch each other because you will short the battery terminals. Enough talking, let's make our first measurement. And as you can see, the voltage is 920, which is quite different from 9 volts we considered in theory. This is not any error. You need to get used to the fact that in the world of electronics there is a difference between theoretical and actual values. Your results might be even more different. This is due to many reasons, but more on that later. I'm sure you have a strong urge to reverse the probe and measure with a red on minus and black on plus of the battery. Go ahead, do it. Your result will be negative value. This doesn't mean the voltage is negative, but it means something else, and I will also talk about that another time. While we are measuring voltage, let's immediately check the voltage across the resistor. The V symbol in a circle is the symbol for a voltmeter, and let's check if there really is any voltage there. So if in future lessons you see a voltmeter symbol, you need to check the voltage on that element. Well, the resistor is connected directly to the battery, so it must show the same voltage. Try turning the range selector and see how the multimeter behaves at other values. Play around with it. Now, how to measure current? On the multimeter, you need to change the dial to DC current measurement. Here you also need to set the range, and we know the current value because it will be about 9 mA. The red test probe is in the right place because there is an milliampere marking, and the probe in this position can measure a maximum current of 200 milliamperes. We will never experience such current in this course, so let the probe in ammeter mode stay in this place. There is one very important rule, so listen to me carefully. Never connect the multimeter in current measurement mode in parallel to an element, never ever. Even more so, don't measure current by connecting the probes directly to the battery. This will damage the meter and you will have to replace the fuse that is inside. We connect the ammeter only in series with the circuit. This means we have to break the circuit and connect between the power supply and the given component. The current must be flow through the multimeter, then it will be measured and then this current returns to the circuit. Let's now check if the current we calculated is really 9 mA. We have the I symbol in a circle which, as you probably guess, in ammeter, positive probe to the battery, plus and negative to the second point. So current flows into the multimeter and flows out through the black probe and goes to the resistor. The result is 9.0 mA, so as you can see, very close to our value, and what I said is true. You are probably asking yourself, but it's not 9 mA. You must not forget that measurements have some error. First, resistors have their tolerances, which I will talk about in the next episode. Second, there is the resistance of the test leads and the meter itself. Third, your battery doesn't give exactly 9 volt at all. To summarize, the result is correct and you have to get used to these slight anomalies. You can measure the actual values of voltage and current and resistance and check if Ohm's law works out. But I'm certain it does. We will do resistance measurements in the next lesson where we will talk in detail about resistors, how to measure them and so on. I think this is already too much information for this time. Let's all this new information sink in. Today was a great episode. We learned a lot of new things. We know what voltage, current and resistance are. We know how to use a multimeter, how to measure voltage and current, and I want to congratulate you on your first measurements. This is another big step in the complete electronics adventure. If you didn't understand some topic, write a comment and I will gladly help you, because remember that my mission on this channel is to teach you electronics and soldering. That's all for this episode. Please like the episode and subscribe to this channel. See you in the next episode. Bye.